research in performance engineering, and particularly performance engineering tools, which is what I do. Possible areas for collaboration with you, and possible ways that you might engage with our student body. So I asked someone, should they be using app dynamics, and I got the answer yes, definitely, so we'll have to talk about that. And but seriously, if you want to come and talk to some students, or have students visit you, or even have a student project that you supervise, I've found lots of people that I've worked with in industry over the years doing that, really enjoy it. It's a chance for you to mould the next generation of IT professionals, which is why, in fact, I'm an academic, but it's pretty cool. So, stuff we do in performance engineering research, I'll talk briefly about why I got into this. The tools, I've got my own names for tools, which MTE is middleware technology evaluation, comes from an old CSIRO project that was being run by their IT group. And I'll talk briefly about those with some pretty pictures, because pretty pictures are kind of what I do as well. And I'll then finish with just some ideas, maybe, some areas that we'd be interested in talking to you about potential collaboration. So why did I get into this? So originally I was in the real world in the 80s, building Infomix 4GL things for local government of all things, and they kind of failed to scale, funnily enough. And so we kind of had to figure out ways to kind of optimize them, and I put that in inverted quotes. And then I started teaching software engineering in a couple of universities in New Zealand. And that was interesting. And again, how do we expose students to the realisms of scaling to large software deployments? It's quite challenging in a university environment. Then I met a group at CSIRO very early, late 90s, early 2000s. It basically had about 15 people building prototypes of, those days it was DCOM and early J2EE technologies to kind of thrash them essentially. And I figured out, I worked out I could actually replace most of their group with automation, which I did, and they all got the sack, but anyway, that's another story for another day. And then I worked with a bunch of companies as a consultant in New Zealand, where they all ran into scaling problems and throughput problems and response problems and so on, and they were lots of fun. So this is Orion Health, if some of you know it. This is First Data Utilities, so two big providers of large systems. So first of all, we start off with this. This is the CSIRO Make People Redundant tool. Essentially what they were doing was building these rapid prototypes, particularly of DCOM applications, to kind of try and figure out how that scaled, message-oriented middleware, and a variety of J2EE based platforms. And no one knew how these performed when you scaled them up, and so they were basically burning people to do that. And when I saw what they were doing, I kind of figured out that, in fact, if we developed a model of the architecture and a model of the load, we could generate all the code these guys were writing. It was taking them literally years, person years to build. Essentially, they're rapid prototypes that we'd thrash under large loads. You deploy them on a whole bunch of clients and servers and thrash them. And you get some sort of idea of, if I built a system based on this architecture, how would it perform? So the idea was a what-if thing. If I structured it this way, the database, the servers, the clients, etc., and use these technologies, how would it run? And so that was the genesis of that tool. This is a ghastly diagram. Again, this is the late 90s. This is a Java applet of some sort, I think. That's a model of some horrendous early Java pet shop reference application. There's an example of code generation. So again, who cares what it sort of says in detail, but essentially it synthesizes from the model a whole pile of code. And we had an early C# one, and as well as a Java one, I think a C++ one as well. And essentially then you kind of generate all these things. So there's, we're using web technologies as well as clients, as well as a whole pile of configuration files that can synthesize from these models. Put them on a whole bunch of clients and servers and stress test them, and then this was using Microsoft Application Center Test, this particular one. So these are some warm up at the start, and kind of running lots of processes and basically thrashing those models. Again, these are quite old, and so that was kind of cool in those days. And basically you didn't write a single line of code, you built a model, and you got actually a relatively accurate idea of how quite a complex enterprise application would perform under quite large stress testing. We had to run this on about 250 clients and about 20 servers at one stage. We took over all our laboratories and our servers a couple of nights to scale it, and that was quite cool. environment. Then we did a bunch of stuff to extend that. So we integrated this stuff in Argo UML, which was an early open source UML tool. So you could do this kind of architecting and what-ifing and so on to stress test architectures. Then there's an Eclipse one we built. That's the Marama MTE. And there's also a Microsoft DSL Tools one, which runs in Visual Studio. And we also built a new load modelling frame. This is called a stochastic form chart, and I'll show an example of one of those. This is a probabilistic load model of a bunch of clients, how they would behave. Originally it was designed for web testing, but we modified it to do server to server and server to database load testing. It's basically a probabilistic model of how a system would perform, and you can scale that to enormous. So we've had several thousand concurrent clients running against a server. Then we generated JMeter scripts and actually Selenium scripts as well, Selenium remote control scripts to run web interfaces. And we synthesised models by web crawling applications. And so these things basically gave us a way to, even with no coding or anything, to actually stress test quite large and sophisticated systems by model-driven engineering. And the current one we're working on, I'll show an example of that, is StressCloud. It's a cloud stressing tool, which again another Eclipse tool, which uses some of those earlier models and some modifications. So again, old pictures, sorry. This is a very simple architecture, incredibly trivial one, but they get huge, of course, as you know, with large systems. That's a stochastic form chart. That's a very simple one, but again, the circles are essentially web pages or some sort of service, and the boxes are transitions with probabilistic descriptions of if I did this thing, where would I go next, kind of thing. And you build up a whole bunch of these models, and it gives you a remarkably accurate model of how a system can be performing under load. And of course, if you then multi-thread them or run them on multiple clients, you get an interesting large-scale stress testing of the target system. There's a JMeter script synthesized from one of those things. There's a JMeter tool, an early version of JMeter, loading that thing and about to run it against the system. There's some generated client, and there's a bunch of these, trivial because they don't scale very well, visualizing in the diagrams and doing, these are 3 different architectural things being thrashed to show you different, I think that one's a throughput. No, sorry, it's a response time visualization. So the idea to kind of, again, through model-driven engineering, give people ways of expressing large-scale architectures and loading of large-scale architectures. This is the latest work we're doing. So I have a project looking at cloud stress testing, and actually it's not specifically cloud. Again, it's virtualized environment. So any set of virtual machines. This can be applied to, we call it cloud because that's the hype these days, but essentially any kind of virtualized platform this could be used for. So this one's another Eclipse tool. Again, it's using JMeter as the load testing tool, but theoretically we could generate other scripts for other load testing tool. We'll talk about the app dynamics, so we can generate some scripts for that. And we monitor a whole bunch of VM virtual machine statistics and energy. So we have an energy platform where we actually monitor how much the various components are consuming, the physical servers, the routers and switches and so on. And so originally this was energy work, because again that's kind of hype these days in my area, but I'm more interested in actually the performance of the VMs under load. So again, this what's that thing? That's another model of a probabilistic model of part of the system. That's a virtual machine description. So there's 3 VMs configured. There's huge numbers of configuration things you can put into it. It will automatically create a whole pile of virtual machines. I think we've got up to several hundred now that we can actually create directly from the tool and then stress test them. Again, you're actually finding physical limits of getting enough clients and servers to actually run this on within the university environment. So I'm having to go offshore and find a really large set of clients and servers to actually be able to use this on at the moment. And there's some examples of monitoring. So that's energy usage. So as you stress or load the application, the energy usage, parts of the deployment go up and down, if you care about energy consumption, that's kind of interesting. It looks good in papers and stuff. How practical it is another matter. This is a more interesting one from my point of view, is various characteristics of the monitored virtual machine. We're using a set of virtual machine monitors to do that, and that's kind of interesting, I think. A related project we're doing with CA Labs is essentially some work with them to extend enterprise system emulation, where we essentially create an environment. So the previous tools were to essentially massively load test systems under test. This one is to give a system under test a very large scale environment. So one of the example systems we've been using is the CA Identity Manager and a PeopleSoft deployment, as well as a few others. And what we do there is give it up to potentially thousands upon thousands of endpoints that the system under test has to interact with. And basically mimicking a very large scale deployment environment. It's incredibly difficult to do that empirically. You can't get 1,000 endpoints to do the testing on. You deploy it and hope it works and fix it up on the fly. So this is the idea is to kind of simulate many thousands potentially of endpoints. What we do is record a bunch of traces, so the system under test talking to the endpoints, and we then build a model of the endpoint and mimic a real endpoint, including the delay and response time, and we've been working on side effects and so on recently. And then it at the moment deals with a bunch of protocols, binary and text. And when essentially when an endpoint gets a request from the system under test, it synthesizes a response. So essentially you get this is the system under test, say the Identity Manager or PeopleSoft server, and here's the clients, and we build up a set of request responses, and from that we synthesize a analysis function. So when I get a request into one of these things, it uses this clustering model that we've developed to find the most likely closest response, modifies that depending on the parameters sent in the request via a translation function, and sends it back. And so we've managed to integrate this into one of CA's products, and works remarkably well to mimic a large-scale deployment without actually having to have those physical endpoints, and quite interested in extending that work further.
So, sorry, John.
Yeah.
Can I ask a question?
Yeah, sure.
So what was the objective?
So the objective is imagine you've got a system under test and you'd like to test an environment with thousands of clients. How do you do that? Is it going to work? It's extremely difficult to get 1,000 clients or 10,000 clients to actually test it with. So the idea is to emulate the 10,000 clients and see how it performs. So we've got this up to about 10 to 20,000 of these. Another way of doing is virtualization, but with virtualization you still have to have a very large number of physical servers to do that, even with very small footprint things. So you end up with a sort of a hundreds limit. This one, we want to get up to tens, if not hundreds of thousands.
So how scalable is this to deployment of other applications? Can it be can someone leverage the capability?
Yeah. So at the moment we can record and replay a bunch of PeopleSoft interactions. We've just been using the order management system, but theoretically you can use others. Twitter, should you want to, but that's just to prove you could do it with JSON. And actually the most interesting one to me is mainframes. So there's a whole pile of mainframes that the system has to talk to. They're the endpoints. The protocol actually no one knows anymore. It's an opaque protocol. So what we've been able to do is by recording transmissions and responses between the system under test and the mainframe, synthesize a set of responses that the real mainframe, if you had it, would give, but we can do it with a multitude of those in an emulation. So again, it kind of allows you to do testing without the large numbers of the target system.
How often did you need to rerun the test to prove your predictability?
So at the moment we've got up to, again, hundreds of thousands of request responses depending on the type of system. Some of them need more than others, and some of the protocols are much more complex than others. As soon as you modify any behaviour of the targets, you've got to rerun the whole lot, and you've got to record them. So the most costly thing is recording the traces, because they can take a long time. You need ideally real requests and responses to record. So that's the blocking point. In fact, we've got a student, a postdoc, working on how to synthesize models from that, so you don't have to rerun them. But it's proving to be interesting.
Can you synthesize those request responses from network snippet tracers?
Yeah, we're using Wireshark to do those, and again, because some of these are binary, some are text. The binary are the most hard. So the LDAP protocol is one we use as exemplar. Oh, and there's a couple of the mainframe ones are binary as well. The text ones are somewhat easier because you've got lots of, the XML ones got lots of kind of scaffolding that you can do quite an accurate replacement, but the binary is a bit tricky.
How do you emulate the? How do you figure out the distributions, or do you just assume Gaussian?
Assume, but one of the things we want to do actually is actually synthesize errors. So where there might not be a response, or different systems behave in a different
That's
behaviour.
right. So how do you figure out the distribution?
Again, the current approach we've taken at is assume uniform, but of course it's not uniform.
With the your tool here, what are the major differences between that and say the industry-based tool like a load runner, HP's load runner?
So again, if you've got the protocol known, one thing is to use existing recordings. If you can record and replay, again, you can use the existing platform. I guess the difference here is, again, we want to emulate that very large number, so we're building a model rather than having, say, a virtualized set of replay agents, if you like, to respond. And again, this is sort of in some sense a CA driver from some of the large systems they're trying to have with very large numbers of clients talking to them. Yeah.
Is it feasible to use this before you've actually written the application? Just putting the activities in that the application is going to be expected to do, so that you don't have to wait for the bozos to write the code before they tell you it's not going to work?
Really good question. Probably, yeah. In fact, I haven't thought of that as a use case, but that's a very interesting.
As long as they've defined the processes, put the necessary delays in.
So again, if you define a protocol and then define exemplars, and we can synthesize some of the exemplars again. So per debate values. That's actually a really interesting suggestion. I think that could be really useful.
Copyrights.
Yeah. Shared IP. Well, CA owns all this, so again, they're the funders of the project.
Sorry,
but anyway.
Sorry, the last question if I may.
Yeah.
What's the difference between this and, say, a cloud-based solution like Flood.io?
Or CA, Lisa?
So this is integrated in Lisa. So essentially, this is a Lisa extension. Yeah. So again, and the key thing they're using is their opaque protocol. You don't have to know the protocol. You can record these unknown and replay them and scale them. So this is actually integrated in Lisa now. Yeah. Again, the cloud-based I think is an interesting one as well. Where again, the idea originally was to make that massively scalable. And even on the cloud, you've got scalability limits for using physical resources. So that each of those models is very lightweight.
So how scalable, or what's the numbers you've taken this up to?
So this thing we've got up to 10,000 from memory. It might be 20,000. So 20,000. Think of it as clients talking to the thing, and it still gives accurate response time. With I think that's one physical server.
So one more question. When you're coming across a protocol you haven't seen before, are you endeavouring to try and identify how that protocol works through code, or are you relying on having the source information?
The protocol is done from the monitoring the interaction trace. It's essentially a Wireshark, the transmissions between the endpoint and the system under test.
So is that pure record replay?
Yeah, it's pure.
So you're not substituting in parameters?
The substitution happens down here, so the translation.
Right, okay.
But not for the record. That's a post. Well, we've already got a good idea, so I've got to take it away and remember it. But again, we're keen to evaluate stuff with you. And again, so for us, evaluating exemplar tools on interesting new application areas and so on is actually an interesting research question for us, and might be for you as well. Is there a use of some sort of lab or platform or set of tools that you can share collaboratively, and we can share with you and other researchers can share with you to do the kind of things that you do? And how do we learn from what you're doing in terms of best practice? How do we advance the field? What kind of extensions to existing tools would be useful? So that is something I've always been very interested in has been limitations of tools that I've tried to use. How do you improve and advance those? And again, for me as an educator, both the practitioners, I guess, particularly students, how do you capture what you do and help others to learn from that? And potentially there's various ways we can work together. There's various funding sources, if you like, for time to do those things. So I'm interested offline to have a chat to anyone who's interested in doing any of those kind of things. And finally, again, the practitioners I've worked with over many years have liked to come and talk to students. So if you like to give a guest lecture, they love war stories, by the way. So systems, I had one guy come and actually demonstrate collapsing a real system in the class, which was kind of cool for the students and me. Don't know what the people at the other end thought of that, but it was all right. Again, we have practitioners. I used to have a practitioner who teach performance or general various kinds of industry tools, but particularly performance tools. If you've got an organisation you're working for that might be interested in hosting some sort of project or just a site visit or something, I love to get the students out to kind of see what you do and get a sense of that. Coming to an environment like this, dare I say, they find this really cool and inspiring. And potentially I've had people supervise various kinds of R&D projects, students and postdocs and so on with me in the past, which is also kind of cool fun. I've got a project with Tullers, and one of the Tullers people is supervising a student with me, and I've got another project with a cloud developing organisation where they're hosting a postdoc in the company. So again, I'm happy to hear any ideas you might have for you to impart knowledge to future IT professionals and practitioners. That's something we're really interested in. Thanks very much.
Questions? So I think one of the reasons why we wanted Dr. John to come and talk to us is, we've been talking about areas where we could work, right? Areas where we could collaborate. And, I think all of us have been students at some point in time. And, if looking back, if we had the opportunity, right, and I didn't, if we had the opportunity to work closely with industry at that stage, right, we would have had a better view of what skills were expected in industry. And I think that's one of the main reasons. The other being that there is fantastic opportunity for us or for organizations in the performance space to leverage some of the innovation capability, the research capability that's available within the labs. So, if any one of you are interested, please reach out to John directly. We'll be working on a few initiatives in the next couple of years. But, please use the opportunity, leverage it. You don't have to, copy me on anything. Please reach out to John directly and work things out. This is just a platform where we want to, to get to know each other and see if there's an opportunity for you guys to work together.
One of the other things I'm really keen on is any examples of really kind of interesting projects that we can show potential students. We have a desperate struggle to get students interested in IT careers in Australia, and cool projects that you're working on. Heard of one or two tonight, just on the side. They kind of inspire young people to think, this is a career that I could contribute to and thrive in, I hope. And so we're always on the lookout for those kind of inspiring kind of ideas to show potential up and coming practitioners of the future. Now, I can't generate them myself.
Where are you contacted, Justin?
Put John Grundy in Google, I'm number one. So.
Is the presentation available for sharing?
Yeah, I can put the presentation on my homepage if you want. Yeah.
So I'll send a copy of the presentation out, including John's contact details. Thank you, John.
My pleasure. Thank you so much.